Normally I would have to bore you for a couple minutes and it's unfortunate that in this country you have to do this. I normally read a disclaimer, a fairly lengthy disclaimer, to protect myself. Forgot the disclaimer. So I'll just open this by saying that nothing said here tonight represents anything except my theoretical work and my theoretical thinking. That's all it is. I'm simply here exercising my First Amendment right to voice my opinion and to express my opinion to you. That's all this represents. It in no way represents any attempt to diagnose, treat, or suggest that you circumvent the care of your medical doctor. I'm not suggesting that anyone go off and self-diagnose and self-treat. This information is strictly of a theoretical nature, and please take it in that vein. With that said, normally when I travel, they fly me all over the United States to put on workshops and just to give seminars. I never check my luggage on the airplane. It's all carry-on. But now they're inspecting liquids. I have some strange liquids in my luggage. So I had to check on, and I hold my breath, and sure enough, my baggage showed up, and I feel very good about that. I want you to know that about 2 years ago, I went to Los Angeles. They lost my bag, and it didn't show up for 4 weeks. This is true, 4 weeks. And when I finally got it, they had ripped off all my clothes. And there was some scientific instrumentation in there. They didn't understand what it was for. They never touched it. It's the only thing that came back. So here I was in Los Angeles with tenny runners, Levi jeans, and a red T-shirt. And the T-shirt said, "Pig Wrestling Contest." And I had to give a talk in front of a group of people with that T-shirt on. And a guy, see, in Montana, this is the way we do it. We poke fun at the North Dakotans, and they poke fun back at us. So the joke in Montana is that a Montanan goes into a bar, and he sees a North Dakotan he knows sitting inside the bar, and he has a big pig next to him. And he says, "Where'd you get him?" And the pig says, "I won him in a raffle." So I must have had that in mind when somebody asked me, "What does that T-shirt mean?" I said, "Oh, in North Dakota, they call it the junior prom." And I caught myself and realized I was horrified that I said that. I hope it was too late to take it back, you see. But anyway, I got a lot of teasing about that. Some guys back home to this day jokingly call me Mr. Junior Prom. So anyway, what I like to do is come out and get to know people. And this is a wonderful group. I want to thank Stephen and Robin for having us here, and Yvonne for all the wonderful work. I mean, she put hours and hours of incredibly hard work into organizing this. So I want to thank you very much. And it's my privilege to come out here and talk to you and share some ideas. And that's all I do is share ideas. I don't come out here to necessarily change anybody's mind. I just want to pass some ideas in front of you. Let you look at those ideas. Let you take a look at them, think about them, ponder over them. Don't quickly dismiss anything you hear tonight. There's a number of good reasons why you should not readily and quickly dismiss what you're going to hear tonight. I have seen some powerful results. I have seen things that I've had people come up to me and say, literally, if there's a miracle, that's the closest I could ever see to a miracle. We've had things happen. We had a woman come to us whose hands had been crippled in like this for years. She couldn't move them. Drank 4 ounces of water and her hands went like this and normalized. People about dropped dead in that room. Can this happen? Oh yeah, it happens all the time. You know why it happens? Because for many, many decades, somebody's telling us that they think they understand something about this organism called the human body, and I'm here to tell you, no, you don't. No, you don't. It operates on levels you don't even begin to understand. And I'm still grappling with it. I don't pretend to know everything. I don't have all the solutions. At any point in history, physicists really just wish they had all the answers. But we don't. We have some of the answers. Some of the things we've come up with, like in quantum mechanics, like QED, quantum electrodynamics, arguably it's the most successful theory in all of science because it's accurate. Time and time again, it never fails. We've never known it to fail. Incredibly accurate theory. It is very rare for somebody involved in quantum mechanics like me to take an interest in biology. Oh, among physics professors, that's a no-no. But you know something? The connections between the principles of quantum mechanics and biology were so obvious, I don't know how everybody just passed them by. It makes no sense whatsoever to me. It's the kind of thing that just slaps you alongside the head, and you say, why is everybody ignoring the obvious here? I think it's because when they become quote-unquote professionals with big degrees, they don't want to step on one another's toes. So, that's the proprietary arena of the medical doctor. Well, no, it's not. And the reason why is because he's killing people. Okay? That's why it's not his proprietary. Especially when it comes to this body. He's not touching it. Why? It's a matter of trust. It boils down to a matter of trust. Okay? When I look at the statistics and the records, you're not going to convince me that you know what you're doing when I look at statistics like that. I know you don't know what you're doing. And don't try to convince me that you do. When I read a book written by a brilliant man, in my opinion brilliant, named Dr. Batmangali, I realized there was something missing. In 25 years, I've never found a human being to be hydrated. Did you know that? I've never found a single human being hydrated. Everybody was walking around inadequately hydrated. Curious. Why is that? Do we not drink water? Oh, some of us drink water. Some of us drink a lot of water. I'd had people come to me that were drinking up to 2 gallons a day, just as dehydrated as the people who were not drinking any water, but were getting all their fluid intake in the form of coffee, tea, pop, and juice. And everybody was just as dehydrated. Well, that didn't seem right. Isn't water supposed to hydrate? The definition of water. Somebody said that tonight. You did.
No, you did.
Yeah. Hydration.
Hydration. If you talk to most scientists
Yeah.
and ask them what hydration is, they say that's where you add water.
That's where you add water.
You add water.
That's where you add water. That's the definition of hydration. When we applied for approval for a label on our initial bottle when we got into this 5.5 years ago, we had a bottling plant in a state out west. I won't mention the state, but they have a lady who's works for their Department of Agriculture. They call her the labeling specialist. And seriously, the labeling specialist. And she said, well, it turns out that, you're going to have to run that label by me, and I'm going to have to approve it, which wasn't true. She didn't have that power to approve or disapprove a label. She was there to keep you out of trouble with the FDA. That was her function. She knew what they required. And you could not say that water was quote-unquote structured. You couldn't have the word structured on the label. You could not make that claim. Why? Because in her words, and maybe this was a bad way for her to put it, such and such a university in our state says water can't be anything but water. Whoa, there's a statement for you. What do you mean water can't be anything? First of all, tell me what water is. You can't find an adequate definition of what water is. Water is H2O. That's fine. Carbon dioxide is CO2. This still doesn't tell me anything. What is water? I know how carbon dioxide feels. My hand is bumping into carbon dioxide molecules right now. But you know what? Why does a bathtub of water feel so much different? Being H2O doesn't explain the difference in the properties, the qualities, the texture. It doesn't come close to dealing with that. Why the big difference between this, people, atmospheric gases, and water? A huge difference. Would you jump from a 10-meter platform into a pool of air? No, you wouldn't. Maybe a pool of water. I'd go feet first. But there's a vast difference here. And of course, the atmospheric mixture of gases, mostly molecules. Oxygen molecules to oxygen atoms pairing up. Nitrogen molecules to nitrogen atoms pairing up. CO2, some individual atoms, small amounts of the rare gases, okay? And then you got all kinds of other garbage mixed in there. Carbon monoxide from exhaust. You've got, if you go to Yellowstone Park, the smell of sulfur dioxide will knock you over, okay? But for the most part, the difference is all of these molecules stay to themselves. They don't get involved with other molecules. That's not the case with water. That's not the case with water at all. We're going to go into that a little bit tonight. First of all, I want to get through this. The physics is I'm going to keep simple, real simple. I give workshops in western Montana, and this lady that puts them on calls it turning on the fire hose. I get lost and start getting into the physics, and everybody, they get lost. And she has to stop me and correct me and, oh, whoa, hold it, you're losing this. I tend to do that. I'm sorry. I won't do that tonight. We'll keep it simple. Let me start by saying this. Almost everything about our experience is determined by one simple thing. It's determined by a charge. It's determined by a charge. And here's what's going on. Everything you feel, everything you perceive in the world around you is an interaction between this particle that carries or mediates the electromagnetic force and the electron shell and the atoms that make up your body. Almost everything we experience is determined by that interaction between the photon and the electron shell. That electron has a negative charge. So I realized several years ago, this is a very, very simple algebraic operation. Now don't get freaked by this, it's just simple stuff. If I'm dealing with the electron that has a negative charge, then parity, time, energy, gravity, and entropy will have the opposite charge, a positive charge. You'll be dealing with positive energy, positive gravity, positive entropy, positive time. But in this simple algebraic operation, as soon as you change any one of the signs, they all reverse. They have to reverse. So, if time becomes negative, everything else becomes negative, but this becomes positive. Okay? Now, I worked from this end of the operation and went in this direction. And the assumption was this. If our experience is determined by the negative charge, which is the electron shells, what can we do with the proton in the nucleus of the atom? You know, there's a lot we don't know about the nucleus of the atom. We know that there's a positively charged entity in there. Seems to be made up of quarks. In this case, the proton is made up of 2 up quarks and a